Remember absolute value function, everyone. Absolute value of x, as you remember from algebra, is defined as the distance between x and the origin 0. So if you try to visualize this, when we talk about absolute value, suppose the origin is just right here, and your x is a number either on the left-hand side or on the right-hand side. The way that you measure the distance is represented by norm or absolute value. So you say that, hey, I have the absolute value of x, which is the distance in how many units from the origin. Okay, so what if you have a number on the left-hand side? What would be the distance there? So suppose you have something like k on the left-hand side. Again, if we try to measure this distance, we're going to say that it is the absolute value of k. But in either case, when you have a distance, it's in the minimum value is 0 or a positive number. Why we say 0? Because if you measure that value at the origin, it becomes 0. So you can say that, hey, the absolute value of 0, which is the distance from 0 to itself, is 0. With the same argument, we can say that, hey, the absolute value of x, if x is positive, is equal to x. But what happens if x is negative? For example, if you have the absolute value of 2, which is the distance from 2 to 0, which is 2. But if I ask you to calculate the absolute value of negative 2, what would be the answer? Since x, in this case, is negative, you cannot just write it as negative 2. You cannot just take x and write x back here. You have to put a negative sign in front of it. So you have to add a negative sign in front of your x to get a positive value. So since this is x, I'm going to put a negative in front of it. So the outcome is negative times negative or positive 2. The distance is positive. So this is the idea of absolute value. We usually summarize it this way. We say that the absolute value of x is if x is more than 0, you just copy down x. If x is 0, you get 0 back. And if x is negative, we have to put a negative sign in front of that negative number to get a positive distance. In more general form, if you have the absolute value of a quantity, this can be written as, if that quantity is positive, just copy down that quantity. If that quantity is equal to 0, then the distance becomes 0. And if the quantity is negative, you have to put a negative sign in front of that quantity to make it to a positive value. Or in simplified mathematical version, you can write down as the absolute value of u. If u represents that quantity, the absolute value of u is, if u is positive, you get u back. If u is 0, you get 0 back. And if u is negative, you get minus u back. Minus u. Why it is important? Because we can use this to find the definite integral. For the definite integral, we have to be careful about the behavior of the graph. For example, suppose I ask you to evaluate the definite integral of absolute value of x minus 1 dx as x ranges between -1 to 2. How do we evaluate this definite integral? So this is the absolute value of x minus 1. If we try to visualize this, in general, the behavior of absolute value of x is a V-shaped graph, right? So we're just going to shift this 1 unit to the right-hand side. So 1 unit to the right-hand side, this is the graph of absolute value of x minus 1. So what's the breakdown of this absolute value? The absolute value of x minus 1 is, if x minus 1 is positive, you get x minus 1 back. If it is equal to 0, you get 0 back. And if x minus 1 is negative, you get negative. So we need a negative sign here. Let me give it a little more space for my negative sign. So you end up with a negative in front of this binomial. So you have to distribute this minus sign. So in more simplified version, the absolute value of x minus 1 is, if x is more than 1, I brought -1 to the other side, it becomes positive, I get the increasing line x minus 1, which you can just see it right here. So when x is more than 1, we have y equals to x minus 1. At 1, the value is equal to 0. When x is equal to 1, we get 0, which is obvious. And when x is less than 1, you have the line (1 minus x). I just distribute the negative sign here into parentheses. So you get a decreasing line, which is on the left-hand side, just right here. So this line, which is a decreasing line, is y equals to 1 minus x. So when you're calculating the definite integral from -1 to 2, take a look. From -1 to 2, you're basically finding this shaded region area here and on the right-hand side. So if you forget about the right-hand side, the function on the left-hand side is 1 minus x. That's why we have to divide this up into 2 pieces. This is the definite integral from -1 to 1 of the function 1 minus x dx plus the second part of the integral plus the definite integral from 1 to 2 of the increasing function x minus 1 dx. So it's all about visualization. How do we graph this absolute value function? And this is the simplest case possible when you have absolute value of x or absolute value of x minus 1, x plus 1, and so on. So on the left-hand side, the integral of 1 is x, the integral of minus x is minus x squared divided by 2. And your x is ranging between -1 to 1 plus the second half of the integral, which is x squared divided by 2 minus x, as x is ranging between 1 to 2. Perfect. So let us substitute 1, -1. We're using fundamental theorem of calculus. You have 1 minus a half minus -1 minus a half, because if you plug in -1 squared is just 1. That's how you end up with this +1 plus the rest of the integral, which is 4 divided by 2 minus 2 minus a half minus 1. Perfect. So this integral is now simplified to algebra. Let me shift this a little bit over here to avoid any confusion. So here you have a half and minus -3/2 plus, okay, this is just 2 minus 2, which is 0, and you get -1/2, which is +1/2. So your integral for now is a half plus 3/2, 4/2, which is 2, 2 plus a half, or 5 divided by 2.